Hi, I'm Stephen Marg. I'm a sales engineer from the UK. I'm with Alessandro Renner, sales engineer from Italy. Our plan is to give you a whirlwind tour through deploying the high availability, SUSE high availability solution on top of a HANA deployment that you build by yourself in a VMware environment. We'll try and give you some of the best practices and so on. Now, I was hoping with this I would get the award for the longest title of any presentation, but we got beaten by one down the corridor I saw on the way in, so it's not so good. So before we get into the content, the first thing I'd like to do is give an absolutely fantastic thank you to Hewlett-Packard Enterprise, the pre-sales team in the UK, who aren't here, but they might be listening to the recording, and the SAP team in Italy, who have helped us with some of the non-SUSE content for this. So they are, of course, sponsors, so please stop by the booth and tell them how we gave them a quick name check and they should be happy. So over the next 45, 50 minutes or so, what I plan to do is just take you through what I think HANA TDI means, and then we'll take a look at some of the best practices when you deploy on top of VMware. We'll take a look at some of the challenges your organizations will see or your customers will see when they start going down the TDI route. And then we'll dive into the HA side and look at, give you an overview of the HA side of things and take a deeper look into the configuration. So I guess the first question is, what is SAP HANA TDI? Well, for me, it's pretty simple, all right? It's what I would call DIY HANA. Now, anybody here been to IKEA and bought a wardrobe or a set of drawers or something like that? Okay, so you get the box home and you do one of two things. You either just get the parts out and start building and see what happens, yeah? Or you take your time to read the instructions, get the right tools, make sure you've got all the right bits, and then you actually normally end up with something that's pretty functional, all right? And that's the idea of this whole TDI framework which SAP have come out with. It's a set of rules, a set of instructions which allow you to ensure that when you've finished deploying HANA in your enterprise or by yourself, it's going to be fit for purpose, okay? Now, TDI has been kind of progressing over the last 4 years. There's been about 4 phases to TDI. The first one, they kind of relaxed the rules around storage, then the compute side of things, and the most recent phase was all about deploying SAP HANA on the Power architecture. But we're at the point now where pretty much a lot of people are doing it. So have a think back to 2010. Was everybody dealing with SAP HANA in 2010? Maybe. What were you doing in 2010? Any Americans here? Let's start off with that. Okay, so I apologize for the BP oil spill in the Gulf in 2010. That was the Brits' fault, obviously. I don't know. And the Super Bowl, was it if my research is correct, I don't know if it's the New Orleans Saints or whoever they won that year. First and only time, apparently. But anyway, it was also the year that HANA was born, okay? It's the year SAP released HANA. And it was pretty simple, okay? You could only buy it as an appliance, a ready-made thing which you bought from one of your 3 favorite hardware vendors. There were appliances available from HP, IBM, and I can never remember the third one. So if anybody knows, please tell me, and I can change my notes for the next time I do this. But if you think about what you could do back in 2010, it was pretty limited, right? The use cases for HANA were pretty small, but this new architecture of having an in-memory database was fantastic. And there were people talking about improvements of speed of 100,000 times over their classic SAP infrastructure. And as soon as you said that magic number to SAP, they whisked you off on a plane to Hawaii to go to their little development and tech center there for you to, help with their research or whatever, or have a holiday. But it was good times. It's a lot less restrictive now, all right? So there are more hardware vendors that will happily sell you an appliance, and there are more models available on the hardware side. So let's look at the deployment options we have today, right? Fast forwarding 6 years. You've got 3 options. Starting on the right, you can, if you want, deploy HANA into a public cloud. All right? SLES for SAP is available and supports HANA both in Azure and AWS. You also have HANA Enterprise Cloud, and there's many hosting options as well, where they take all the pain of HANA away from you. And you'll be able to deploy it, and they'll look after it and do all the patching and everything for you. And whilst there may be some initial cost savings there, it might not be the cheapest way in the long run. Certainly the least hassle, but not necessarily the cheapest. Okay, the appliance model, still probably the most popular deployment model we have. Probably has around, in the UK at least, well over 40% of most HANA deployments tend to be via the appliance route, all right? And it's pretty simple why people choose that. It is the easiest way to get HANA out into your enterprise, all right? The full stack, the software, the hardware has all been approved by SUSE, SAP, and the hardware vendor, tied up with a nice little bow and left on your doorstep for just a few tens and tens of thousands of pounds. But there is a third option coming, which is proving ever more popular, and that's the TDI option. And that makes it a lot more flexible for you. You don't have to buy a new piece of hardware for HANA anymore. You can find something you have lying around, as long as it meets the criteria of SAP that they lay out and everything, and they're happy with that. You can go and deploy HANA on that if you want. And that gives you the chance to reduce those upfront costs of getting HANA out by reusing hardware and storage that you have in place. But what are the challenges? Okay, so the first one is, on the left we have the something which represents the appliance model, all right? Like I say, everything's tied with a nice little bow, one support contract, one throat to choke. I don't like that term, but it's essentially what you get when you buy an appliance. And it's proven to be pretty reliable over the last few years. Your support agreements will change, all right? When you start deploying on your own hardware with your own install of SUSE, your own storage, perhaps using your own SAN, suddenly you've got support agreements which come from all over your organization, and that might reduce the SLA that you can offer back to the business. So it's something to bear in mind. And depending on which bits of the internet you read, some people think that TDI might not be the best solution for those absolutely mission-critical environments. And that's why we're going to talk about the HA thing, because it's a way to increase that SLA. So looking at the implementation effort. Now, I've already mentioned that the implementation effort on the appliance side is very low indeed, okay? You buy a SKU, it turns up, you turn it on, change a few configuration settings, and off you go. Suddenly, on the TDI model, it's a huge effort for either your systems integrator, the customer, your IT team, whoever's actually rolling this out has got a huge amount of work to do. And the example is, I guess, if you're a customer, my wife likes to spend a lot of money on carpenters coming in to build stuff because I'm pretty useless at it, so you've got to make sure you've got the right skills in place to get things deployed. So, in terms of validation, obviously the appliance is fully validated by all parties involved, but on the TDI side, it's the customer or the SI that has to manage that validation. And the way they do that is with the hardware check tool from SAP, so it's something you can just download. Very easy to install, you just download it. It's a little JSON file which you have to edit to say what you're checking. Sometimes it'll be the SAP support team that'll ask you to run the checks on the storage and the network. But you can actually check your landscape pretty easily to make sure the compute side of things works perfectly okay. Now, hopefully, when you run it, you just get back a nice screen with the word success, which just appears time after time after time. And if you do, then you're in a pretty good place. If you're not, you've got to figure out what's wrong. But again, the onus is down to you to figure that out. The tool does change quite a lot, so always make sure you use the latest one to make sure you get the latest checks. And once you have run that, you're pretty much good to go. So what I'll do at this point is just to hand over to Alessandro, talking about a little more about the VMware side of things.
Okay, thank you. Can you hear me? Yep, thank you. So let's move to the topic about HANA on VMware. By the way, why talk about VMware? Basically, because everyone is doing it. And SAP is the third most common application that gets certified. And it's major. The partnership between SAP and VMware is a long time, since 2007. And there are validated architecture for SAP HANA since May 2014. And the news is that now vSphere 6.0 is now certified for scale-up HANA instances. So let's see at what is the version and the supported. I don't want to get into all the details about how many hosts per cluster, VMs per cluster, CPUs per host. By the way, the common installation is 1 terabyte to 3 terabyte. That it's too much for vSphere 5.5. And by the way, 80% of the workloads could fit into HANA. And the SAP application HANA platform is fully certified to run on vSphere up to 4 terabyte. No requirements to reproduce on physical hardware. But if you look at what is supported on the different version of vSphere, you can see that scale up to 1 terabyte is supported on vSphere 5.5, Update 2, and vSphere 6.0, even for non-production and production environments. Then, if you look at other configurations like scale up to 4 terabyte, vSphere 6.0 is certified for non-production and production environments. And what about the scale out configuration? It's certified up to 1 terabyte for production environment and non-production environment for vSphere 5.5 and vSphere 6.0. If you go up to 4 terabyte, the certification is just for vSphere 6.0. But if you want to look into details about all the supported metrics for all the configurations, you can look at the link in VMware.
Nothing bigger than 4 terabytes scale up or scale out.
4 terabytes is non-production for scale out.
Non-production.
Yeah, I mean scale out is not properly supported on vSphere 6, and yeah, up to 4 terabytes for your scale up physical.
Yeah, currently yes. Currently yes. Yeah. Yeah. And what about the performance? The official line says that there is 3 to 12% drop in performance when you virtualize HANA on VMware, because you know HANA is a huge workload that needs a lot of resources. But the good news is that there is an HPE document that states that there was a huge increase in performance on vSphere 6.0. That is measured in 6% of increase of performance using HANA on VMware and in such kind of configuration. So the performance is getting better and better after the release of VMware. Couple of configuration about the storage performance. For TDI storage, must meet some key performance indicator. There is a tool from SAP that the customer should use in order to be compliant with the performance indicator in order to be certified or supported. What we see that usually to meet the KPI, maybe you can bring down the production, keep up only the QA and production, and this is not the usual, the preferred way to meet this requirement. It's important because the storage is one of the most critical part in order to have HANA performing in the right way. So let's move to some best practice, some basics about how to implement TDI configuration on VMware. Set memory reservation for SAP HANA virtual machines. It's important. It's important also to configuring the Paravirtual SCSI controllers and network adapters using Paravirtualization that improves the performance a lot. Enable HyperThreading on the ESXi host and use dedicated networks for NFS storage, vMotion, management, and client network. It's important to use vMotion and VMware snapshot during non-peak times because this consumes resources from the virtualization host. And use latency network traffic optimization when needed on the client-facing adapter, but not on the bandwidth adapter for storage or SAP HANA internode networks communication network cards. And use the HANA tool to determine if the storage subsystem is able to meet the HANA KPI, like I said in the slide before. Another important thing is about the tools, the VMware tools. SUSE works with VMware to integrate the VM tools into operating system using the open VM tools. That's a huge improvement because the tools are not available. I mean, you can use the VMware tools from VMware, but you will find the open VM tools into the distribution, and you will be supported by SUSE and VMware using those tools. And this eases a lot the maintenance and the operations of the tools, because you will get all the updates through the SUSE channel updates. There are a lot of components that are part of the tools, like VMware Balloon for physical memory management, other drivers to provide efficient communication between the virtual machines and the hypervisor, a new generation of paravirtualized network interface designed for performance, to meet performance, and the same for the paravirtualized SCSI device. And as I said before, it's really important to remember that those tools that are part of SLE and SLE for SAP applications are part of the distribution and are fully supported by VMware through our L3 support agreement. What about VMware HA? VMware HA is able to meet some of the HA requirements for HANA environment. Why? Because basically VMware HA takes care of the host, the virtualization host, but doesn't care about what happens in the virtual machines, in the sense that at least VMware HA can restart a virtual machine. It's not aware of what happens into the workloads. And I mean, the availability level that can be reached is to 99.9% in the best case. And here is when high availability from SUSE comes into the play, adding value and features. And we'll see what means this.
Thanks. Thank you. Swapping dance again. Get around the games. Okay, thanks. So when you start building everything yourself, there's going to be a number of challenges you're going to be facing. Okay. So you've got more choice of hardware. You can find stuff lying around as long as it's on the list of SAP HANA's approved list of hardware, then that's fine. All right, as long as it's got the right processor, you're fine. But then suddenly you're not getting this thing, nice, neat package anymore. You've got to figure out, you've got to do the OS install. You've got to figure out how you need to configure it, get all the right packages on there. And then we come back to this question about achieving SLA. All right, again, your support agreements are all over the place with a lot of different suppliers. We need to find a way in order to maximize that. And that's what we'll be talking about in the second half of this, when we get onto the HA side of things. And patching and maintenance, that was kind of always the responsibility of the customer or the IT department with the appliance. But what we saw time and time again in a number of customers were, because the IT team hadn't built this appliance, they weren't happy to look after it and maintain it. So now they'll be involved right from the start, so but perhaps that process will get a little bit easier. So here's some details about what you might be faced with when you come to install HANA. So has everybody done some work with SAP before? Yeah. So you'll be familiar with SAP Notes. Now, if you have a quick look at how many SAP Notes on HANA there are, around the 500 mark, okay? Now, doing some slightly suspicious mathematics, we reckon that's about 500,000 words to read through. Right? That's a considerable amount of detail that you need to fight your way through. You need to figure out various parameters and how you need to set those, and if you want to go and grab all the packages you need to go and find 24 packages which don't come on the core SLES distribution. And that's if you were doing it completely by hand, all right? And to put that into a little bit of perspective for you, 500,000 words is the equivalent of the first 2 books in the Game of Thrones series. I don't know, most people have probably just watched the TV programs, right? But if you read the books, the first 2 is about 500,000. If you like your classics, War and Peace is about 500,000 words as well. And I can guarantee you they are more entertaining than all those SAP notes you've got to wade through, all right? But the thing is, we try and make life easy for you. So with SLES for SAP, when you install that, it is simply a case of ticking the HANA base button as you do the install. We'll get all those packages for you. They're already included. We'll set up most of the configurations. We suggest that you still check them, but we'll get the configuration pretty much right for HANA. You might want to tweak a few things. And this, so we've taken a lot of the effort of doing this deployment out, taken a lot of the effort of doing the deployment away from you guys. However, one thing again, which will change, is the file system. All right? HANA wants certain things in certain places, and it's the responsibility now of the customer or the IT team to figure out how big these file systems need to be, to mount them, to figure out which storage they're going to be on, and make sure that make sure they're the right size. And it's a really well documented process. There's a lovely SAP note you can follow, which tells you if you've got this amount of RAM, just times by 3, make it that big, and so on. Like I say, very well documented. But the important thing is the responsibility has shifted away from if you're going to do this yourself. So
yeah, thank you, Stephen. So let's move to the topic about system replication. What does it mean? And what HANA does out of the box. Basically, the system replication that is available in HANA out of the box is a disaster recovery. I mean, there is a primary and a standby system, and everything is synchronized to the second node, and basically you don't have a shared disk in order to, let's say, having this. The takeover is quite fast. It depends from the sites, but the takeover is quite fast. Why? Because it's everything preloaded in memory, okay? But the failover tends to be a manual process, okay? Nothing monitors the nodes and taking action on some policies that you want to decide in order to, let's say, manage the failover in an automated way, okay? And that is where high availability extension from SUSE comes into the play, okay? Basically, we use Pacemaker and Konsole to add some intelligence to the cluster, okay? Pacemaker is a policy engine that decides what action to take during certain events, okay? The technology is the technology that is used for any kind of high availability cluster for SUSE. How many of you set up cluster with SUSE? Okay. So, you know, the technology is basically the same, okay? We add a virtual IP address where the clients connect to, but the system replication is still managed by HANA itself, okay? It's not automated. So what's happened? When a primary node fails, at a certain point, the system replication will also stop, okay? And the pacemaker will act and move the virtual IP to the second node. So the clients still connect to the secondary system, to the failover system. And Pacemaker also will start all the scripts which need to run in order to promote the secondary node to be the primary, okay? And remember that without the HA extension from SUSE, this should normally be a manual process, okay? So we add some resources and the automation in order to make this process automated. Second, when the secondary becomes the primary, you should automatically reconfigure the old primary, that's now the secondary, to be a secondary and restart the system replication in the other direction, okay? But we normally recommend not to do that in an automatical way. Why? Because usually you may want to check into the failed system what went wrong, or if there is something that must be fixed before to restart again the process in the other way, okay? So the default setting is not to reconfigure automatically the primary to be the secondary, and vice versa. But you can change. If you want, you can change this. Okay. And we try to make life easier to administrators, adding a wizard into the web interface of high availability extension from SUSE that makes possible to configure the system replication resource agent with all the information needed in order to make easy the configuration of the cluster. This is particularly important because those resource agents are available on / for SAP applications that brings in the same ISO and the same product, the high availability extension, and makes possible to have the certification and the support for this kind of thing. This wizard is quite easy and makes life really easy to configure all the resources needed. We'll see later what are the resource agents in details. So let's talk about other parts of the configuration and best practice and tips that must be keep into consideration about operating system virtualized on VMware for HANA. First of all, there are some settings in the VMX file that must be configured. For example, one should the time that should be synced through VMware only in case of resume. And this option can be added with the vSphere client or inside the .vmx file. Another really important topic is about the NTP protocol. HANA is very sensitive about time, NTP protocol, and the option Thinker Panic 0 tests the NTP daemon to control the time under all the circumstances, even when the drift is really abnormal. So much more than 125 seconds, okay? And this option must be the first in the configuration file. And the other option important is that the virtualized hardware clock should not be used. Obviously, you can disable all the services that are not needed by the operating system when it is virtualized on VMware. So like microcode, IRQ balancer, ultrasound for the sound card, and other configurations, like multipath, for example. And what about the I/O scheduler? There are several different I/O scheduler choices available, but the preferred one for virtual machine is called no operations. Okay. Basically, it does not attempt to guess the storage by implementing a sophisticated elevator algorithm, and it tends to work very, very good on virtualized environment, on virtual machines. How to change the default schedule from CFQ to NOOP, putting this parameter in the configuration file of the bootloader. So what about the file system? Should be some performance impact for some operations. For example, record the metadata for access to the file to the file system. And so a good way to improve the performance and the latency is about putting the mount options for all the file system, no A time and no dir A time for this kind of configuration in virtualized environment. There is another tool interesting that you can use. This is part of the high availability extension. It's called Cluster Tools 2. You can do a lot of things, but one interesting thing that you can do is to prepare the environment for ESX. there's a little script that you can apply to the virtual machine. It's called CS prepare ESX VM, and basically it's a good way to configure the hypervisor, the virtual machine to run virtualized and in a cluster environment. Okay.
So that's modifying the operating system running in the virtual machine.
Absolutely, yeah. So all the
What was it called again?
hang on, prepare CS prepare VM. Oh, cluster tools 2 is the package.
It's part of the high availability extension. Yep. So let's look at the configuration deeper.
Okay, thanks.
Back to Stephen.
Okay. So we're at the point where you have your hardware deployed, your OS is installed, maybe you've deployed SAP so far. But what I'm talking about today is the performance optimized failover. So these are the prereqs that we're looking at for that. Sorry, I just need to change something here. Okay, so we're talking about a 2-node cluster. Okay, for performance optimized, obviously we can't support any more than that. And we're talking about scale up only. All right. As the people that have done HA in the crowd know, these machines have to be on the same network. You can't have them in completely different data centers. And we also don't want anything else running on that secondary node. All right. And the reason being is it just takes too long to stop it and then restart it. You don't quite get the performance that you need. So here's the basic stack that we're working towards. Okay, 2 virtual machines, each with their own local disk configured as we saw before. Running the SUSE OS. We're going to put HANA on, talk about system, we'll talk about system replication briefly, and then we'll take a closer look at that HA stack. So before you rush off and start deploying HANA, system replication, and all the HA products, please at least patch and register your box. The reason being is twofold. One, half the stuff you need doesn't just come on the DVD, okay? You have to get it from the SUSE mothership or an SMT server that you've synchronized things down to. The other thing is certain versions of HANA marry up with certain versions of our resource agent that we ship with HA as well. So you need to make sure the two marry together. It's a lot better now. The easiest thing to do is just get the latest of both. And there is a matrix out there which says which versions of our resource agents go with the various versions of HANA and so on, and system replication. Okay. So again, deploying system replication, very well documented process. All right, so we won't go through it in its entirety. But the important thing is this. All right, so I went out to a customer about a year ago, and they said, "Yeah, your HA stuff isn't working. Look, when we try and fail over, it just hangs." And we looked in the logs, and you could see that we're an automation layer. Okay, so we looked in the logs, and we could see that we were running all the right commands, and it was indeed hanging. So we stripped off the HA. We tested system replication natively all by itself. Surprise, surprise, it hung at that level there. Okay, so before you dive in and start doing HA, please test and verify system replication is working. Test the failover, fail it back. Do all the things that you need to do before you try and automate a process which may or may not work. All right, so that's my only tip. The other thing is with system replication itself, there are a number of modes that you can choose from. All right, now if you're in, are you in IT or mostly in IT, I guess, looking after the Linux side? All right, this isn't your choice. All right, this will be down to the SAP team. There'll be an SAP basis team that know all about SAP. They will decide which one that they want to try and implement. However, if they choose full sync, you can walk away because our HA product, I don't think, supports the full sync replication. All right, the most popular one that I see is the third one, the sync mem one there. So, like I say, not your decision, but just be aware there are different types available. So let's have a quick peek at the architecture again. So one small pink SLE HA blob expands up into a whole bunch of other ones, and Alessandra is taking you through some of this. So CoralSync sits at the bottom. It's our messaging layer. It handles the membership of the cluster. A couple of things you need to be aware of. All right, it's constantly communicating between these two nodes, checking who's alive, which nodes are up, which ones are down. If you're a little concerned about security or paranoid or whatever, you can encrypt that traffic. It's just a case of one setting in the CoralSync file, CoralSync configuration file, and a key which you need to copy around, all right? And that'll keep your security people happy that when these servers talk to each other, it's all encrypted. So the next layer up is Pacemaker. It's taking information that CoreSync gives it. It's taking information from the resource agents, and it's going to make decisions on what action to take. And of course, we need a way to control the nodes within the cluster. So we need some kind of fencing solution. The ability for one node to kill off another if it thinks it's not doing its job properly. And for that, we use something called SPD, or split brain detection, or STONIF block device. And I've heard about 4 or 5 other ways of saying SPD. Nobody will tell me which one it is. Maybe I'll have a chat with engineering in there and they can tell me. Yeah, well, there's another one. Thanks very much. Yeah. But you need this, okay? So whilst you've got 2 completely independent VMs, you will need some shared storage. We'll, again, talk about that in a couple of slides' time. And then the final bit that sits on top of it is the resource agents. These are the bits that are actually doing the clever bits, the bits that are keeping an eye on your HANA estate, and will start and stop everything that's needed. So as far as the install is concerned, I'm not going to insult you by reading this out. It's very simple. Providing you've registered your box, you've got access to all the channels. 2 commands to zipper in the HA pattern and the system replication documents and packages. All right. Please remember, you probably already know this, but it's the HANA system replication resource agent is only supported on SLES for SAP applications. So if you have a standard SLES box and you think you can shoehorn everything in and get it working, that's fine. But when you phone up the support to say it's not working, the phone might get put back down again. But, so please be aware of that. So let's talk about SPD. All right. STONIF block device, storage-based F in the corner over there. It's a shared disk, all right? It sits there. Both nodes need to be able to write to it. It's just a way of the nodes being able to communicate in the event that the network between the 2 fails, all right? Now, a few very exciting commands up there, but the one that's worth pointing out is you can list out this SPD, all right? It's normally just a single device, and you can see that each node in the cluster will have a slot. And if, in this case, node SUSE-01 wants to kill off node 2 for any reason, it can just write something into that particular block on the disk. Next time SUSE-02 takes a look at that particular part of the disk, it will panic and die and won't play any more part in the cluster. Now, as far as VMware is concerned, VMware ESX users will naturally go to a shared VMDK. That's perfectly fine. You might want to look at an iSCSI target as well if you're not comfortable running shared disk files. And the important thing is the HA product supports up to 3. So if you're going to have 3 shared VMDK files, don't put them all on the same data store. Spread them around your organization. Make sure you don't have any kind of single point of failure. Now, if you do go down the shared VMDK route, like I say, it's perfectly okay. But again, this is going back a few years. VMware were maybe a little bit squishy about the supportability of shared disks between nodes. A lot better now. Fantastic link at the bottom takes you to this huge table which tells you which features and functions like snapshots and live migration and so on are supported and which ones are not. But what you will need to do if you are going to share a disk, you will need to add the multi-writer flag only for the SPD drive. Okay, and so you definitely don't want to share any other disks like the OS disk or the data disk or anything like that, because that could really get messy very quickly. So in terms of the basic cluster setup, as Andrew said earlier, we have a lovely wizard which takes you through. In fact, in terms of setting up the cluster, you just need to run one script, HA cluster init, and it will configure the bulk of the cluster for you. You then run the wizard in Hawk, and that will configure your resource agents for you. Now that's fine, but it's no fun. All right, when you come to troubleshoot things, you want to maybe know a little bit more about what's underneath. So what I'm going to do is take you through, they're terrible slides, okay? They're all basically a series of commands, but we'll talk around them. It enables me to easily pick out some of the detail that I want to talk to you about and why the settings are like they are, okay? So an alternative to our Pretty Hawk wizard is something called CRM. It's our cluster resource manager, all text-based, keeps Linux people very, very happy. But if you start looking at the basic cluster configuration, you could, if you want, you don't have to use the scripts we provide. You can type this in and it configures it all by hand if you want. But let's just pull a couple of these commands off just to discuss quickly. So STONIF enabled is true, right? If we don't have that shared block device, if the cluster can't see it, your cluster won't start. So that will always be set to true because we do need it for our 2-node cluster. The third one, resource stickiness, we set that to 1,000, okay? So what we're saying here is if you have a resource, your HANA database sat on node 1, we don't want it arbitrarily flipping around your cluster just because it feels like it. Or maybe if it fails over to node 2 for some reason, you bring node 1 back up again. We don't want it failing back just because it prefers node 1. So we try and keep them as static as possible unless we need to move them at all. And then finally, anybody that's deployed HANA and tried to start and stop the databases will know that they have a huge timeout. They take a long time to do things, so we try and mirror that in the configuration as well. So we will allow 600 seconds for something to happen before we say it's failed, right? And that tends to be enough. You shouldn't have to change these, but if you are playing about in the lab, then it's something you can do quite easily. So here's what we're aiming for, okay? Here's our 2 stacks on either side. We need to talk about 3 resource agents, okay? HANA topology, the database one, and an IP address. All right, and we'll talk about, again, some of the configuration in that. But you can see here we've got the HANA topology one. That runs on both nodes. I'll explain why shortly. And then we have the database, again, mirroring what Alessandro said. You have one that's a primary mode. The other one sits in a secondary mode as well. And then finally, the third one to worry about is the IP address. So let's talk about the topology resource. All right, and in terms of pure HA terms, in terms of the SUSE side of things, it's the easiest one to configure. It's also the one you have to worry about the least, because in terms of HA, it doesn't actually do a lot. All right, and we'll see what it actually does in a second. But you only need to tell it what the database SID is and what the instance number is, and it will sit there on a server constantly checking in, seeing what's running. You know, are you a primary, are you a secondary, and basically looking at the landscape on the local machine. All right, now that resource will always run. It might not understand the messages it's getting back. It might be getting complete garbage back from whatever it's running, but the resource itself will always run quite happily. In terms of what it's doing under the hood, so the HANA topology resource, it's just running some SAP scripts. So anybody that's deployed HANA will recognize some of these calls that we make into the OS. So it's just running that particular Python script, passing the results, and then actually puts the results into the what we call the CIB, or the cluster information base, which is a shared database that CoreSync copies around for us. And that way, every node will know what every node thinks it's doing. So it's pretty clever. Okay, but again, most resource agents are just scripts, so you can debug them pretty easily. So the second one, the database one, again, 3 parameters which are worth worrying about. So please don't change these, all right? So they should be something like this, but you can change them depending on what you want to do, all right? So prefer site takeover. That should always be set to true, all right? That basically says, if node 1 dies, would you like node 2 to take over, all right? Now, the reason you've built this HA cluster is for that to happen. So if you set that to false, then the first node will just restart, which completely negates the entire idea of having a HA cluster in the first place. The third one there, automated register. When your node dies, or if your database dies, again, something which Alessandro talked about earlier, you have the choice, okay? When the machine restarts, or when the database needs to restart, we can register that automatically as a secondary. It's about 50-50. So all the deployments I've seen, we get some system admins say, I want to restore my redundancy as quickly as possible. Let's just get that secondary node back in, get system replication going again, and restore my cluster to health. The other people will take the more cautious approach, the least destructive approach, and they'll say, no, don't automatically register that failed node back in. I want to see what happened. I want to check the database, I want to check the hardware, and so on. And the third one there, the duplicate primary timeout, that's there for one reason. If you have 2 nodes, and let's say the first node crashes, the second node will take over, become the primary. If for some reason that first node comes back up again, it will also try and make itself the primary, because that's the last configuration it had. That's what it thought it was before it died a death. So you'll have 2 primaries, okay? Now, HANA will put the second one on hold. It won't let 2 primaries register at the same time. But this figure is set to 2 hours. And basically, it gives you 2 hours for a SAP admin or a systems admin to come in and say, actually, no, I won't automatically register, or to say, yes, go on and register. But after 2 hours, after a node failure, if this is set to true, that node will, that crash primary will re-register straight away. And again, most of the deployments, chatting with the consulting team, they've got no real need to change that. They're quite happy. It's worth noting that if it's just the database that's crashed, and we still have some sort of control over the operating system from within the cluster, that 2-hour window's irrelevant, because we have the capacity to stop the database and restart it as a secondary anyway, in which case it will register almost straight away without the 2-hour wait. So the final resource at the top was an IP address. It's the absolute simplest one to configure. All right, doesn't take long to start. It is important that you have it, and then once you've got the IP address, you just have to co-locate the IP address and the primary instance of the database, that they always follow each other. So as soon as the master or the master version of the primary database is up, the IP address will be over there as well. So in terms of wrapping up, this is kind of, we kind of took you on a whirlwind tour of all sorts of things, which we pulled from all sorts of places. But essentially, we talked about having a couple of ESX servers, perhaps in their own cluster, sharing disks, things you need to worry about there, make sure system replication works, and then we talked through all the different, or the 3 resource agents and the technology underneath that. Now, if you want to know more, the guy that wrote most of this stuff has a session at 16:45, but I don't know which room it's in. But it's well worth tracking down. He'll go into the resource agents in a little more detail, and also look at some of the other use cases like scale out and cost optimized and various other things. Very clever chap. So yeah, feel free to drop that, or he's mostly sat on the SLES for SAP desk in a tech showcase. In the meantime, thank you for listening. I hope it was of some use, or you managed to pick up something along the way. If you've got any questions, come back at 16:45 and ask Fab. No, okay. Has anybody got any questions? In that case, thank you for your time, and enjoy the rest of the show. Cheers. Thank you.